So with tables in GIS, we have two basic categories of such tables. One is called an attribute table, and that stores data associated with a spatial feature class right within the GIS geodatabase. So this is the attribute table we typically refer to with a vector spatial feature class. A standalone table can store tabular data from any source, including, like, for example, an Excel spreadsheet. It can even be stored in a text file. Usually these text files are related back to columns somehow, such as this CSV, comma separated variable file. And we can also have database files. All of these can exist outside of the GIS, but they can either be joined to the GIS through the attribute table, or they can be made into a GIS layer if they have X and Y information associated with them. Here's what the table looks like. So the table has both rows going across this way and columns going up and down. Each one of these rows represents, in this case, a separate county in the United States. So this GIS layer has all of the US counties in the United States, but this one row here represents Loving County, Texas. So each row represents a different county in the United States, and each column represents all of the associated attributes that can go with that. For example, each county has a unique FIPS code, and in this case, Loving, Texas's FIPS code is 48301. The rows of the attribute table are called records, and the columns of the attribute table, such as FIPS, are called fields. There's also one column that has a unique ID, this object ID or sometimes feature ID, that cannot be changed by the user. This is a unique code, such as this 336, that uniquely identifies this one row or record as Loving, Texas. So a flat file is just a database that stores data as rows of information in files. It's simple and robust, and it's easy to search or query. For example, we could have a flat file database for all of the customers that we have, all of the service calls that we need to make to satisfy those customers, if it's an electrical utility, how much each one of those customers use, or if people have to go out on those service calls, who's going out on those service calls. Each one of these could be a unique database. However, typically with database management systems, we use some sort of structure, such as this hierarchical database management system. In this case, we see that this database, which is the customers, can be linked with a unique customer ID to service calls that need to be made for those customers. These customers can also be linked with their unique customer ID to their electrical usage, so they know with that same customer ID how much those individual customers could be billed. But for these service calls, we also might need to link to who our service personnel are who might be able to go out on that call, what their unique employee ID are, so that we can assign each one of these personnel to a unique service call. So in this way, we have sort of a hierarchy where we kind of come down through the hierarchy in order to get to these end results here. An alternative and more flexible way to model things is with these relational database management system. So this, once again, stores data in multiple places, just like the previous one, but these links can be established in any way that we see fit. So these service calls could be linked to a unique customer ID and a unique employee ID, but these links can just be made on as the need arises for these links to be made. So they're very flexible. They're ideal for open-ended application when we don't even know what kind of questions we're going to ask before we ask those questions of our database management system. And these relational DBMSs are by far the most common type used in GIS applications.